So you can see that this quantity here is not equal to this quantity here. So it's not odd. So therefore it's neither. Okay. So that's symmetry. Moving on to wait a minute, DIS, and then we need to go to asymptotes. Okay. So let's snip one more time. Actually, that's not the way I want it. I want to snip only a part of this. So let's just go this part here. Okay, so that would be number 4 would be A for asymptotes. And I think when you're looking at the domain, we saw clearly that x cannot be equal to 2, so the vertical asymptote is equal to x equals 2. Okay. And then since the degree of the numerator is exactly 1 more than the degree of the denominator, okay, so the degree of the numerator is 2, the degree of the denominator is 1, so the top is exactly 1 more than the bottom. So then there's a slant asymptote, and we need to do x minus 2 is equal to x squared minus 2x plus 4. And so your slant asymptote, SA, is y is equal to x. Again, remember asymptotes are lines, and therefore they have to have equations. So my slant asymptote is y equals x. Okay, next is really R and M together. Okay. Let me get a new snip here, because this is going to be where all the work is. So far it's been all pre-calc stuff. Now it's all calc. Okay. So 5 and 6. All right. So to get the relative min-max, you got to differentiate. So find the derivative. You get keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, which is just 1, all over the bottom squared. Okay. And since we need to find critical numbers of this, let's go ahead and simplify. So the top becomes 2x squared minus 6x plus 4 minus x squared plus 2x minus 4, all over x minus 2 quantity squared. Okay. So that becomes x squared minus 4x all over x minus 2 quantity squared. And so the critical numbers are obtained by setting x squared minus 4x equal to 0, which gives you x times x minus 4 equals 0. So x equals 0 or 4. So these are your critical numbers. Okay, 0 and 4 are critical numbers. Next, we need to figure out whether they are mins or maxes. Now, there are 2 ways of doing this. You could either do the first derivative test, or you could do the second derivative test. Now, we're going to need the second derivative for doing point of inflection. So why don't we just bite the bullet and do the second derivative of this. So remember, the first derivative is this guy here. Okay, I'm going to get a new snip so we can start out from there, and then do the second derivative of that. Okay. So let's go snip this. And so my f prime of x was equal to x squared minus 4x all over x minus 2 quantity squared. Okay. So which gives me f double prime is keep the top, okay, differentiate the bottom. Okay, let me just take a look at it. No, wait a minute. Keep the bottom, x minus 2 quantity squared, differentiate the top, minus keep the top, differentiate the bottom, all over the bottom squared.